Hi everyone. I wanted to give you your notes for solving radical equations. So this is probably something that you've done before, and the concepts that we're going to use are definitely things that you've used in the past, but we're going to kind of just be putting it all together. So the first thing I wanted to point out is this property here. So we have the square root of 3 squared. So 3 squared inside the radical. So that's technically the square root of 9, right? And the square root of 9 we know is just 3. Now if we were to write the square root of 3 as a whole squared, we would have the square root of 3 times the square root of 3, correct? Because anything squared, it's just itself multiplied by itself. So square root of 3 times square root of 3 would give me 9. And that's just going to give me 3. So basically, if I square a radical, my answer is going to be whatever's inside the radical. Alright, so let's go ahead and try this first problem. Alright, so when I'm solving an equation, my goal is to get x by itself, correct? So in order to do that, how do I get rid of this attached 3 here? Well, it's being subtracted, so I can just add it to the other side. So in other words, I am isolating the radical. That's what we're going to call that. We're isolating the radical, so we want to get the radical by itself on one side. Alright, so now, how did I get rid of this radical here just to get what's on the inside? Well, to do that, I need to square my radical. And remember, whatever I do to one side, I have to do to the other. So I also have to square the other side of the equation. So, I isolated the radical, I got it by itself. Now to get rid of the radical, I'm going to square it. Because if I had the square root of x squared, I'll just write it here on the side. That would be the square root of x times the square root of x, right? Or in other words, the square root of x squared. And what is the square root of x squared? It's just x. So that's how I get x by itself here. So if I square a radical, I'm just going to get whatever's on the inside, right? So x equals, and we know that 4 squared, oh, I'm sorry, that's not 4. I already messed up on the first example. I forgot to add on this side, so when I added 3, 4 plus 3 is 7. Right, so same idea, different number. So 7 squared on this side is going to be 49. Alright, so my first step is to isolate the radical. If you want to write these down, you can. I'm going to make another video later where I'll have the steps written out. But this is just me talking through these examples. So first you isolate the radical, so you get the radical all by itself. Then you are going to square the radical so that you can get rid of it. Because when you square a radical, you're just going to get whatever is on the inside as your answer. So when you square the radical, you have to do the same to the other side. So you're going to square both sides. That's step 2. And then you just solve the equation like normal. So in this case, this is our answer because that gives us x by itself. Alright, so if we wanted to check this to see if we got the correct answer, all we would have to do is plug it back into the equation. So the square root of x, which is 49, square root of 49, minus 3 equals 4. Square root of 49 is 7. And does 4 equal 4? Yes, so that one will work. Alright, let's try example number 2 here. So first step, I need to get the radical by itself, right? Because that's where my x is. So I'm going to add 7. So square root of x, that's all that's left over here. It's going to equal 10. Alright, now remember, to get rid of this radical here, to get x out, I have to square it. And since I squared this left side, I also have to square the right side. So square root of x squared gives me x, and 10 squared is 100. So I get the x equals 100. If I wanted to check, I would have square root of x, which is 100, minus 7 equals 3. So what is the square root of 100? It's 10. So does 10 minus 7 equal 3? Yes, so that answer will work. All right, moving on. All right, first step, we need to isolate the radical. So get our radical on one side and everything else on the other side. So this equation is already isolated. The radical is already on one side by itself. There's nothing attached over here outside the radical. So my next step is to square the radical to get everything out of that. Okay, and whatever I do to one side, I have to do to the other side. So, if we remember from our last examples, anytime I square a square root or a radical, my answer is just going to be whatever's on the inside. So 2x minus 3 equals 1. Alright, so I squared my radical to break this inside stuff out. Now I can solve the equation like normal. So how would I solve this? I add 3. So I get 2x equals 1 plus 3 is 4. Divide by 2. X equals 2. Alright, and if I wanted to check, I'd have 2 times 2 minus 3, because I plugged in 2 for x here, equals 1. So square root of 4 minus 3 equals 1. Square root of 4 minus 3 is 1. And the square root of 1 is just 1. So that answer is correct. Alright, I'm not going to check the rest of these. I just wanted to show you how this would work. Alright, let's try another example. Alright, so first step, I need to get my radical by itself on one side. Alright, so I need to get rid of anything attached over here. So this 20, I'm going to move it over here. Alright, so now I have square root of y plus 3. I move that 20 equals 20. Now that my radical has been isolated, I need to get this, get these terms out of the radical. And how do I do that? I'm going to square it. And remember, since I squared one side, I have to square the other side as well. So when I square a radical, my answer is just going to be the contents on the inside. So y plus 3 equals 20 squared. That's going to be 400. Alright, so if I wanted to solve this one, I could subtract 3. And I'll get that y equals 400 minus 3 is 397. Alright, now if I wanted to check this example just to make sure that I got the correct answer, if I plug in 397 here for y, that would work. But I could also just plug in 397 here after I squared it. So when I have my whole equation, I can plug that in, and it would also work. So let's try that. We've plugged it into the radical before. I'm going to plug it in right here. So checking. 397 plus 3. Does it equal 400? Yes, 400 equals 400. So if you don't like that method, you can always do the one at the top. So 397, if I plugged it in here for y, 397 plus 3 is going to be 400, right? Minus 20 equals 0. So the square root of 400, if you need to do that in a calculator, you can. But that is going to be 20. So 20 minus 20, does it equal 0? Yes. So either way you check it, that equation, that answer will work. All right, now let's look at this last example. So I want to isolate my radical. Well, my radical is on one side, but I also have a radical on the other side. How am I going to deal with this one? Well, it's not as complicated as you might think. How do we get our terms in the radical outside of the radical? How do we break them out? Remember, in our last examples, we just squared it. All right, so I'm going to square them. That's how I'm going to get my contents inside the radical to come out. And it works because even if I was just going to square this one side, I also have to square the other side because I have to do the same thing on both sides. All right, so if I square this side, I'm just going to get 3y plus 1 equals, and if I square this side to get everything out, I'm going to get 2y plus 6. All right, now I can solve like normal. So I'm going to try to get my y terms on one side. So I'm going to subtract this 2y over here. I also want to get this 1 out of the way. So I've moved my y terms over here. I'm going to move all my non-y terms to the other side. So I'm going to subtract 1 here. So 3y minus 2y gives me y, and 6 minus 1 gives me 5. All right, and again, if I wanted to check, I could plug in here. So square root of 3 times 5 plus 1 equals square root of 2 times y, which is 5, plus 6. All right, so square root of 3 times 5 is 15. 15 plus 1 is 16. Square root of 2 times 5 is 10. 10 plus 6 is 16. So 4 equals 4. That answer is correct. All right, so as far as your steps go, first, you need to get the radical on one side. In this case, we didn't have to get it on one side because there's nothing else attached over here outside the radical. So we want to get the radical by itself so we can get everything out of it. Second, you're going to square both sides of the equation. So we're squaring it so that we can break these contents out of the radical. So first, isolate the radical. Second, square both sides. Third, you solve the equation like normal. I hope this video helps you. I'm going to make another short video with some examples with just a few more steps, but it's nothing that we haven't seen before. But if you guys have any questions at all, feel free to contact me. If you need to, if we need to do another meet, we can do a meet class. I'm working on your final exam, and I'll have that information to you the next week or so, hopefully. So I miss you all so much, and I hope you're doing well.